Picture this, a swirling cosmic masterpiece, glowing with colors so vivid they seem almost unreal. This is the Orion Nebula, a place where stars are born and mysteries abound. It's not just a distant cloud of gas and dust, it's a living, breathing laboratory of the universe, filled with phenomena that challenge everything we think we know about space. From glowing jets of gas to hidden stars shrouded in mystery, the Orion Nebula is a treasure trove of cosmic wonders. In this video, we're diving deep into 25 of its strangest and most fascinating phenomena, each one more mind-bending than the last. So, if you've ever looked up at the night sky and wondered what secrets it holds, get ready. By the end of this journey, you'll see the Orion Nebula in a whole new light. Let's explore the unknown together. Now, let's zoom into the very heart of the Orion Nebula, where one of its most dazzling features awaits, the Trapezium Cluster. This cluster is a tight-knit group of young, incredibly bright stars, and it's not just a pretty sight. It's the engine that powers much of what we see in the nebula. These stars are like cosmic newborns, only about 1 million years old, which is practically a blink in the grand timeline of the universe. But don't let their youth fool you, they're already making a massive impact. The Trapezium Cluster is responsible for the intense radiation that lights up the surrounding gas and dust, creating the glowing spectacle we associate with the Orion Nebula. This radiation doesn't just illuminate, it also shapes the nebula, carving out cavities and sculpting the landscape of this cosmic nursery. But here's where it gets even more fascinating. This cluster is a stellar nursery, a place where new stars are born. The intense radiation and stellar winds from these young stars compress nearby gas and dust, triggering the formation of even more stars. It's like a cosmic chain reaction, with the Trapezium Cluster at the center of it all. What's truly remarkable is how this cluster challenges our understanding of star formation. The sheer density of stars packed into such a small space is unlike anything we see in our own galactic neighborhood. It's a reminder that the universe is full of surprises, and the Orion Nebula is no exception. So, as we marvel at the Trapezium Cluster, we're not just looking at a group of stars, we're witnessing the birthplace of countless worlds, a place where the story of the cosmos continues to unfold. And this is just the beginning. There's so much more to discover as we journey deeper into the mysteries of the Orion Nebula. Now, let's shift our gaze to another breathtaking feature hidden within the Orion Nebula: proplyds, or protoplanetary disks. These swirling rings of gas and dust are more than just cosmic eye candy. They're the very cradles of future planetary systems. Imagine a young star still in its infancy, surrounded by a vast spinning disk of material. Over time, this material begins to clump together, eventually forming planets, moons, and even asteroids. That's exactly what's happening in these proplyds, and the Orion Nebula is one of the best places in the universe to study them. The discovery of proplyds was a game changer for astronomers. Before their observation, the process of planet formation was largely theoretical. But with the help of powerful telescopes like the Hubble Space Telescope, we've been able to capture stunning images of these disks in action. What's incredible is that these proplyds come in all shapes and sizes, some appearing as bright, glowing rings, while others are darker and more compact. Each one tells a unique story about how planetary systems might come to be. What makes proplyds so significant is their role in helping us understand our own solar system's origins. By studying these disks, scientists can piece together how planets like Earth formed billions of years ago. The Orion Nebula, with its abundance of young stars and proplyds, acts as a cosmic laboratory, offering us a front-row seat to the early stages of planetary birth. It's a reminder that the processes shaping our universe are ongoing, and that the story of creation is far from over. But here's something even more fascinating: not all proplyds survive. The intense radiation from nearby stars, like those in the Trapezium cluster, can strip away the outer layers of these disks, leaving behind only the densest material. This means that while some proplyds will go on to form planets, others may be destroyed before they even get the chance. It's a cosmic race against time, and the Orion Nebula is the perfect place to witness this delicate balance between creation and destruction. As we continue our journey through the Orion Nebula, the proplyds remind us that even in the vastness of space, the smallest details can hold the keys to understanding the grandest mysteries. And with every discovery, we're one step closer to unraveling the secrets of how worlds are born. Next, we'll dive into another iconic feature of this celestial wonder, the Great Orion Nebula M42. Stay tuned. Now, let's turn our attention to the crown jewel of the Orion Nebula, the Great Orion Nebula M42. This dazzling region is not only the most prominent part of the nebula, but also one of the brightest and most studied features in the night sky. Spanning an impressive 24 light-years across, M42 is a sprawling cosmic cloud of gas and dust, illuminated by the intense radiation of its young, hot stars. Its sheer size and brilliance make it visible to the naked eye, even from Earth, which is why it's been a favorite target for both amateur stargazers and professional astronomers for centuries. What makes M42 so captivating is its vibrant mix of colors and textures. The nebula glows with hues of pink, red, and blue, created by the ionization of hydrogen and other gases under the influence of ultraviolet light from nearby stars. This stunning visual display is a testament to the dynamic processes at work within the nebula, from star formation to the sculpting of gas clouds by stellar winds. For anyone with a telescope, M42 offers a breathtaking view, revealing intricate details like wispy filaments and dark lanes of dust that weave through its glowing expanse. But M42 isn't just a feast for the eyes, it's also a treasure trove of scientific discovery. Its brightness and proximity to Earth, at just about 1,300 light-years away, make it an ideal laboratory for studying the birth and evolution of stars. Astronomers have used M42 to observe everything from the earliest stages of star formation to the complex interactions between young stars and their surrounding environment. It's a place where the raw materials of the universe come together, offering us a glimpse into the processes that shape galaxies and, ultimately, life itself. For stargazers, M42 holds a special place in the heart of the winter sky. Located in the constellation of Orion, it's easily found just below the 3 stars that make up Orion's belt. Whether you're using a small backyard telescope or simply gazing up on a clear night, M42 never fails to inspire awe. Its beauty and accessibility have made it a gateway for countless people to fall in love with the wonders of the cosmos. As we marvel at the Great Orion Nebula M42, we're reminded of how much there is to explore in our universe. It's a beacon of light in the vast darkness, inviting us to look closer and discover the secrets it holds. Next, we'll explore another fascinating feature of the Orion Nebula, the Orion Bar, a boundary of gas and dust that tells its own unique story. Stay with us as we continue this journey through one of the most mysterious and beautiful regions in space. Now, let's shift our focus to one of the most intriguing structures within the Orion Nebula, the Orion Bar. This striking ridge of dense gas and dust stands out as a glowing boundary, illuminated by the intense ultraviolet light pouring from the young, massive stars nearby. The Orion Bar isn't just a beautiful feature, it's a dynamic region where 2 very different environments meet, creating a fascinating interplay of light and matter. At its core, the Orion Bar acts as a boundary between 2 distinct zones within the nebula. On one side, you have the ionized gas, where the intense radiation from nearby stars strips electrons from atoms, causing the gas to glow brightly. On the other side lies the molecular gas, a cooler and denser region where atoms bond together to form molecules. This transition zone is a cosmic laboratory, offering astronomers a unique opportunity to study how radiation interacts with matter in space. The ultraviolet light from the Trapezium cluster, a group of young, hot stars at the heart of the Orion Nebula, plays a crucial role in shaping the Orion Bar. As this powerful radiation slams into the dense gas and dust, it creates a shock front, heating the material and causing it to glow. This process not only lights up the bar but also drives chemical reactions, transforming simple molecules into more complex ones. It's a place where the raw ingredients of the universe are being reshaped, setting the stage for future star and planet formation. What makes the Orion Bar particularly fascinating is its layered structure. As you move from the ionized region toward the molecular side, the temperature and density of the gas change dramatically. This gradient allows scientists to observe how different types of molecules form and survive under varying conditions. For example, near the ionized edge, you'll find molecules like carbon monoxide, while deeper into the molecular region, more complex organic molecules begin to appear. These observations provide valuable clues about the chemical processes that occur in star-forming regions across the universe. The Orion Bar also serves as a natural shield, protecting the molecular gas behind it from the full force of the ultraviolet radiation. This shielding effect allows pockets of cooler gas to survive, creating the perfect conditions for new stars to form. In this way, the Orion Bar isn't just a boundary, it's a cosmic incubator, playing a vital role in the ongoing cycle of star birth and evolution. As we explore the Orion Bar, we're reminded of the delicate balance that exists within the Orion Nebula. It's a place where light and darkness, heat and cold, and creation and destruction all come together in a breathtaking display of cosmic forces. Next, we'll dive into another remarkable phenomenon within the Orion Nebula Herbig-Haro objects, the glowing jets of gas ejected by young stars. Stay with us as we continue to uncover the mysteries of this incredible region of space. Now, let's turn our attention to another captivating feature within the Orion Nebula Herbig-Haro objects. These glowing jets of gas are like cosmic fireworks, ejected at incredible speeds by young stars still in the process of forming. Named after astronomers George Herbig and Guillermo Haro, who first studied them in detail, these objects are not just visually stunning, they play a crucial role in the story of star formation. Herbig-Haro objects are created when newborn stars, still surrounded by swirling disks of gas and dust, begin to channel material away from their poles. As this material is ejected, it collides with the surrounding gas and dust at speeds of hundreds of kilometers per second. These high-speed collisions heat the gas, causing it to glow brightly and creating the striking, elongated shapes we observe. It's a dramatic process, one that reveals the raw energy and chaos of a star's early life. But these jets aren't just spectacular to look at, they're also vital to the star formation process itself. As a young star grows, it accumulates material from its surrounding disk. However, not all of this material makes it onto the star. Some of it is funneled away by magnetic fields and ejected as jets. This process helps regulate the star's growth, preventing it from becoming too massive too quickly. In a way, Herbig-Haro objects act as cosmic pressure valves, ensuring that stars form in a controlled and balanced manner. What makes Herbig-Haro objects even more fascinating is their interaction with the surrounding nebula. As these jets plow through the gas and dust, they create shock waves that compress the material, triggering new waves of star formation. It's a ripple effect where the birth of one star can set off the birth of others nearby. This dynamic interplay highlights the interconnected nature of the Orion Nebula, where every event has the potential to influence the entire region. One of the most remarkable aspects of Herbig-Haro objects is their variability. These jets can change dramatically over relatively short periods, sometimes even within a few years. Astronomers have observed jets that shift direction, brighten, or fade, providing a real-time glimpse into the chaotic environment around young stars. This variability makes Herbig-Haro objects a valuable tool for studying the early stages of stellar evolution, offering insights that static objects simply can't provide. As we marvel at these glowing jets, we're reminded of the incredible forces at work in the Orion Nebula. Herbig-Haro objects are a testament to the dynamic and ever-changing nature of star formation, where even the smallest events can have far-reaching consequences. Next, we'll explore another mysterious feature hidden within the nebula, the Beklin-Neugebauer object, a young star shrouded in infrared light. Stay with us as we continue to uncover the secrets of this extraordinary region of space. Now, let's shift our gaze to one of the most intriguing mysteries within the Orion Nebula, the Beklin-Neugebauer object. This enigmatic feature, discovered in the 1960s by astronomers Eric Beklin and Jerry Neugebauer, is a hidden gem that reveals itself primarily in infrared light. Unlike the dazzling jets of Herbig-Haro objects, the Beklin-Neugebauer object is shrouded in thick clouds of dust, making it nearly invisible in optical wavelengths. But when observed in infrared, it shines brightly, offering a rare glimpse into the earliest stages of stellar evolution. What makes the Beklin-Neugebauer object so fascinating is its youth. It's believed to be one of the youngest stars in the Orion Nebula, possibly only a few thousand years old. To put that into perspective, our Sun is over 4.5 billion years old. This object is essentially a cosmic newborn, still in the process of gathering material from its surroundings and settling into its role as a star. Its infancy makes it a critical subject for astronomers studying how stars are born and how they evolve over time. The Beklin-Neugebauer object is also surrounded by a dense cocoon of gas and dust, which plays a key role in its development. This material not only fuels the star's growth but also obscures it from view, creating the need for infrared observations to peer through the veil. The intense heat generated by the young star warms the surrounding dust, causing it to emit infrared radiation. This glow is what allows us to detect and study the object, even though it remains hidden in visible light. One of the most puzzling aspects of the Beklin-Neugebauer object is its movement. Observations have shown that it's traveling through the nebula at an unusually high speed, leaving behind a trail of heated gas. This motion suggests that the object may have been ejected from a nearby star-forming region, possibly due to gravitational interactions with other young stars. Such events are rare but not unheard of, and they provide valuable insights into the chaotic environment of stellar nurseries. The Beklin-Neugebauer object also serves as a reminder of how much we still have to learn about star formation. Despite decades of study, many questions remain unanswered. For instance, how exactly does a star accumulate mass in its earliest stages? What role do magnetic fields play in shaping its growth? And how do interactions with other stars influence its development? These are just some of the mysteries that the Beklin-Neugebauer object continues to pose, making it a focal point for ongoing research. As we ponder the secrets of this young star, we're reminded of the Orion Nebula's role as a cosmic laboratory. Every object within it, from the glowing jets of Herbig-Haro objects to the hidden glow of the Beklin-Neugebauer object, tells a piece of the story of how stars are born and evolve. Next, we'll venture into another dense and dusty region of the nebula, the Kleinman Low Nebula, a hotspot for massive star formation. Stay with us as we continue to unravel the wonders of this extraordinary stellar nursery. Now, let's turn our attention to another fascinating corner of the Orion Nebula, the Kleinman Low Nebula. Nestled deep within the heart of this stellar nursery, the Kleinman Low Nebula is a dense, dusty region that serves as a hotspot for the birth of some of the most massive stars in the universe. Discovered in the 1960s by astronomers Douglas Kleinman and Frank Lowe, this nebula has become a key area of study for understanding how high-mass stars come into existence. What sets the Kleinman Low Nebula apart is its extreme environment. Unlike the more visible parts of the Orion Nebula, this region is shrouded in thick clouds of dust, making it nearly opaque in visible light. However, when observed in infrared wavelengths, the nebula reveals its secrets. The dust, heated by the intense radiation from newly forming stars, glows brightly, allowing astronomers to peer into its depths and study the processes at work. This makes the Kleinman Low Nebula a treasure trove of information about the early stages of star formation, particularly for stars that are many times more massive than our Sun. One of the most striking features of the Kleinman Low Nebula is the sheer scale of its star-forming activity. Here, massive stars are born in clusters, surrounded by swirling disks of gas and dust. These stars form much faster than their smaller counterparts, and their intense radiation and powerful stellar winds begin shaping the surrounding nebula almost immediately. This creates a dynamic and chaotic environment where the forces of gravity, radiation, and magnetic fields all play a role in determining the fate of these young stars. The importance of the Kleinman Low Nebula lies in its ability to teach us about the birth of high-mass stars, which are relatively rare but play a crucial role in the evolution of galaxies. These stars burn through their fuel quickly, living fast and dying young in spectacular supernova explosions. Their short lives mean that observing them in their infancy is a rare opportunity, and the Kleinman Low Nebula provides a front-row seat to this cosmic drama. By studying this region, astronomers can gain insights into how these massive stars form, how they influence their surroundings, and how they contribute to the chemical enrichment of the universe. Another intriguing aspect of the Kleinman Low Nebula is its connection to the larger Orion Molecular Cloud Complex. This vast network of gas and dust extends far beyond the visible boundaries of the Orion Nebula, and the Kleinman Low Nebula is one of its most active regions. The material here is constantly being compressed and heated, creating the perfect conditions for star formation. This interplay between the nebula and the larger cloud complex highlights the interconnected nature of star-forming regions and underscores the importance of studying these environments as a whole. As we explore the Kleinman Low Nebula, we're reminded of the incredible diversity and complexity of the Orion Nebula. From the hidden glow of the Beckmann-Neugebauer object to the bustling activity of the Kleinman Low Nebula, each region offers a unique window into the processes that shape our universe. Next, we'll take a step back to examine the broader structure that encompasses the Orion Nebula, the Orion Molecular Cloud Complex. Stay with us as we continue to uncover the mysteries of this extraordinary cosmic landscape. Now, let's zoom out from the Kleinman Low Nebula and take a broader look at the Orion Molecular Cloud Complex, a sprawling network of gas and dust that serves as the cosmic cradle for the Orion Nebula and its neighboring regions. This immense complex stretches across hundreds of light years, making it one of the most significant star-forming regions in our galaxy. It's here, within this vast expanse, that the raw materials for new stars and planetary systems are gathered, waiting for the right conditions to ignite the process of stellar birth. The Orion Molecular Cloud Complex is not just a single entity but a collection of interconnected clouds, each with its own unique characteristics. These clouds are primarily composed of molecular hydrogen, the most abundant molecule in the universe, along with traces of other gases and dust particles. It's this dense mixture that provides the fuel for star formation. When regions within the cloud become dense enough, gravity takes over, pulling the material together until it collapses under its own weight, giving rise to new stars. This process is ongoing, with different parts of the complex at various stages of star formation, from dense cores just beginning to collapse to fully formed stars illuminating their surroundings. One of the most fascinating aspects of the Orion Molecular Cloud Complex is its connection to other well-known nebulae in the region. For instance, the Flame Nebula and the Horsehead Nebula, both iconic features of the Orion constellation, are part of this larger complex. These nebulae are essentially pockets of gas and dust that have been shaped by the radiation and winds from nearby stars, creating the stunning visual features we observe. This interconnectedness highlights how star-forming regions are not isolated events but part of a larger, dynamic system where the birth of one star can influence the formation of others. The role of the Orion Molecular Cloud Complex in star formation cannot be overstated. It's a bustling hub of activity where the interplay of gravity, radiation, and magnetic fields shapes the destiny of countless stars. The complex is also a treasure trove for astronomers, offering a unique opportunity to study the entire life cycle of stars, from their earliest stages in dense molecular clouds to their eventual emergence as fully formed stars. By observing different regions within the complex, scientists can piece together the intricate processes that govern star formation and gain insights into how our own solar system might have formed billions of years ago. Another key feature of the Orion Molecular Cloud Complex is its ability to reveal the broader picture of galactic evolution. The stars born here will eventually disperse, enriching the surrounding space with heavy elements forged in their cores. These elements, in turn, become the building blocks for future generations of stars and planets. In this way, the complex is not just a star factory, but a vital contributor to the ongoing cycle of cosmic creation and destruction. As we explore the Orion Molecular Cloud Complex, we're reminded of the sheer scale and complexity of the universe. From the dense cores of the Kleinman Low Nebula to the sprawling expanse of the molecular cloud, each region offers a unique perspective on the processes that shape our galaxy. Next, we'll turn our attention to another nearby marvel, the Flame Nebula, a glowing region of hydrogen gas that adds yet another layer of wonder to the Orion constellation. Stay with us as we continue our journey through this extraordinary cosmic landscape. Now, let's shift our gaze to another breathtaking feature of the Orion constellation, the Flame Nebula. This glowing region of hydrogen gas, also known as NGC 2024, is a striking example of how the interplay of light and matter can create some of the most visually stunning phenomena in the cosmos. Located just to the east of the iconic Orion's belt, the Flame Nebula is part of the larger Orion Molecular Cloud Complex, making it a close neighbor to the Orion Nebula itself. But what sets this nebula apart is its dramatic appearance, resembling a fiery blaze against the dark backdrop of space. The Flame Nebula's vivid glow is powered by the intense radiation from a cluster of young, massive stars embedded within it. These stars, some of which are only a few million years old, emit powerful ultraviolet light that ionizes the surrounding hydrogen gas, causing it to emit a characteristic red glow. This process, known as fluorescence, is what gives the Flame Nebula its fiery appearance, but the story doesn't end there. The nebula is also crisscrossed by dark lanes of dust, which absorb and scatter the light from the stars, creating intricate patterns that add to its dramatic visual appeal. One of the most fascinating aspects of the Flame Nebula is its connection to the Orion Nebula. Both are part of the same vast molecular cloud complex, meaning they share a common origin and are influenced by the same cosmic forces. However, while the Orion Nebula is a bustling stellar nursery teeming with young stars, the Flame Nebula represents a slightly earlier stage in the star formation process. Here, dense pockets of gas and dust are still collapsing under gravity, setting the stage for the birth of new stars. This makes the Flame Nebula a crucial piece of the puzzle in understanding how stars form and evolve within these massive clouds. The illumination of the Flame Nebula is also a testament to the power of nearby stars. The brightest star in Orion's belt, Alnitak, plays a key role in lighting up the nebula. Its intense radiation not only ionizes the gas but also shapes the surrounding dust, creating the dark, filamentary structures that give the nebula its distinctive look. This interaction between starlight and interstellar material is a reminder of how interconnected the cosmos truly is, with one star's light shaping the appearance of an entire nebula. As we marvel at the Flame Nebula, we're reminded of the dynamic and ever-changing nature of the universe. It's a place where the raw materials of stars and planets are constantly being reshaped by the forces of gravity, radiation, and time. Next, we'll turn our attention to another iconic feature of the Orion constellation, the Horsehead Nebula, a dark silhouette that stands in stark contrast to the glowing gas around it. Stay with us as we continue to uncover the wonders of this extraordinary region of space. Now, let's journey to one of the most recognizable and beloved features in the night sky, the Horsehead Nebula. This iconic dark nebula, officially known as Barnard 33, is a striking silhouette of dense gas and dust set against the glowing backdrop of the emission nebula IC 434. Its distinctive shape, resembling a horse's head, has made it a favorite among astronomers and astrophotographers alike, capturing the imagination of anyone who gazes upon it. The Horsehead Nebula's formation is a fascinating tale of cosmic interplay. It's part of the larger Orion Molecular Cloud Complex, the same vast region that houses the Orion Nebula and the Flame Nebula. The dark, dense material that forms the Horsehead is primarily composed of cold molecular hydrogen and dust, which absorbs the light from the bright emission nebula behind it. This creates the dramatic silhouette effect that makes the Horsehead so visually striking. The nebula's shape is sculpted by the intense radiation and stellar winds from nearby stars, particularly Sigma Orionis, a hot, young star that illuminates the surrounding gas. What makes the Horsehead Nebula so captivating is not just its appearance, but also its role in the broader story of star formation. The dense material within the nebula is a potential site for future star birth, as gravity slowly pulls the gas and dust together. However, the intense radiation from nearby stars is also eroding the nebula over time, a process known as photoevaporation. This delicate balance between creation and destruction is a reminder of the dynamic and ever-changing nature of the cosmos. For astrophotographers, the Horsehead Nebula is a dream target. Its unique shape and contrast against the glowing gas make it a challenging yet rewarding subject to capture. The intricate details of the dark nebula, combined with the vibrant hues of the surrounding emission nebula, create a stunning visual spectacle that showcases the beauty and complexity of the universe. It's no wonder that images of the Horsehead Nebula often grace the covers of astronomy magazines and inspire countless stargazers. As we marvel at the Horsehead Nebula, we're reminded of the artistry of the cosmos. It's a place where light and shadow dance together, creating breathtaking scenes that tell the story of star formation and cosmic evolution. Next, we'll explore another fascinating feature of the Orion constellation, the Running Man Nebula, a lesser-known but equally intriguing region of gas and dust. Stay with us as we continue our journey through the wonders of the Orion Nebula and its surroundings. Now, let's turn our attention to a hidden gem nestled near the Orion Nebula, the Running Man Nebula. Officially designated as Sharpless 279, this intriguing region of gas and dust may not be as famous as its neighbors, but it holds its own unique charm and mystery. Its name comes from the striking silhouette of a figure that appears to be running, created by dark lanes of dust cutting through the glowing gas. This distinctive shape has captured the imagination of astronomers and stargazers, offering a fascinating contrast to the more well-known features of the Orion constellation. The Running Man Nebula is part of the larger Orion Molecular Cloud Complex, the same star-forming region that gives birth to the Orion Nebula and the Horsehead Nebula. What makes this nebula stand out is its intricate interplay of light and shadow. The glowing gas, primarily hydrogen, is illuminated by the intense radiation from nearby young stars, while the dark dust lanes absorb and block this light, creating the dramatic Running Man silhouette. This contrast between bright emission and dark absorption is a hallmark of the nebula's appearance, making it a captivating subject for both observation and photography. One of the most fascinating aspects of the Running Man Nebula is the role of stellar winds and radiation in shaping its structure. The young, hot stars in the region emit powerful ultraviolet light and stellar winds, which ionize the surrounding gas and push the dust into intricate patterns. Over time, these forces sculpt the nebula, creating the dynamic and ever-changing shapes we observe. This process is a vivid reminder of the constant interplay between creation and destruction in the cosmos, as new stars are born while their energy reshapes the environment around them. For astrophotographers, the Running Man Nebula offers a unique challenge and reward. Its delicate balance of light and dark, combined with its relatively faint glow compared to the Orion Nebula, requires careful observation and precise imaging techniques. Yet, the effort is well worth it, as the resulting images reveal a stunning tapestry of cosmic artistry. The nebula's subtle hues and intricate details provide a glimpse into the complex processes at work in star-forming regions, making it a favorite target for those who seek to capture the beauty of the night sky. As we explore the Running Man Nebula, we're reminded that even the lesser-known corners of the universe hold incredible wonders. Its unique shape and the forces that shape it offer a fascinating glimpse into the dynamic processes of star formation and cosmic evolution. Next, we'll venture into another remarkable feature of the Orion Nebula, the integral-shaped filament, a massive and twisted structure that reveals even more about the complexity of this stellar nursery. Stay with us as we continue to uncover the mysteries of the Orion Nebula and its surroundings. Now, let's shift our gaze to one of the most intriguing structures within the Orion Nebula, the integral-shaped filament. This massive, twisted ribbon of gas and dust stretches across the nebula, weaving a complex tapestry that reveals the dynamic forces at play in this stellar nursery. Its name comes from its distinctive shape, resembling the mathematical integral symbol, a fitting nod to the intricate processes that define its existence. The integral-shaped filament is a testament to the power of gravity and magnetic fields in shaping the cosmos. This colossal structure, spanning several light years, is composed of dense molecular gas and dust, which serve as the raw materials for star formation. Within its folds, pockets of gas collapse under their own gravity, igniting the birth of new stars. But what truly sets this filament apart is its twisted geometry, a result of the interplay between gravitational forces and the magnetic fields threading through the nebula. These fields act like invisible threads, guiding and sculpting the gas into its distinctive, sinuous form. One of the most fascinating aspects of the integral-shaped filament is its role as a cosmic conveyor belt, funneling material toward regions of intense star formation. As gravity pulls gas and dust into the filament, it becomes denser and more concentrated, creating the perfect conditions for new stars to emerge. At the same time, the magnetic fields help to stabilize the structure, preventing it from collapsing entirely under its own weight. This delicate balance between collapse and support is a key factor in the filament's longevity and its ability to sustain ongoing star formation. The forces shaping the integral-shaped filament also give rise to some of the most dramatic features within the Orion Nebula. Shock waves from nearby young stars and stellar winds ripple through the filament, compressing the gas and triggering bursts of star formation. These energetic processes create a dynamic environment where the filament is constantly being reshaped and reformed. Over time, this interplay of forces results in the intricate, ever-changing patterns that make the filament such a captivating subject for study. For astronomers, the integral-shaped filament offers a unique window into the processes that drive star formation on a grand scale. By studying its structure and dynamics, scientists can gain insights into how gas and dust are distributed within star-forming regions, and how these materials are transformed into stars and planetary systems. The filament's complex geometry also provides clues about the role of magnetic fields in shaping the cosmos, shedding light on one of the most fundamental forces in the universe. As we marvel at the integral-shaped filament, we're reminded of the intricate beauty and complexity of the Orion Nebula. This massive structure, shaped by the forces of gravity and magnetism, is a vivid reminder of the dynamic processes that govern the birth of stars and the evolution of galaxies. Next, we'll delve into another fascinating aspect of the Orion Nebula: the role of magnetic fields in shaping its structure and influencing star formation. Stay with us as we continue to unravel the mysteries of this cosmic wonder. Now, let's turn our attention to one of the most invisible yet powerful forces at work in the Orion Nebula: its magnetic fields. These unseen lines of force play a crucial role in shaping the nebula's structure and guiding the processes that lead to the birth of stars. While we can't see magnetic fields directly, their effects are written across the nebula in the swirling patterns of gas and dust, revealing a hidden hand that orchestrates the cosmic dance of star formation. Magnetic fields in the Orion Nebula act like cosmic architects, influencing how gas and dust move and interact. Imagine these fields as invisible threads weaving through the nebula, guiding the flow of material and preventing it from collapsing chaotically. Without these fields, the gas and dust would simply clump together under gravity, forming stars in a haphazard manner. But with magnetic fields in play, the process becomes more orderly, allowing for the creation of intricate structures like the integral-shaped filament we just explored. One of the key ways magnetic fields shape the nebula is by regulating the movement of ionized gas. As young stars within the nebula emit intense radiation, they ionize the surrounding gas, stripping electrons from atoms and creating a charged environment. Magnetic fields interact with this ionized gas, channeling it into specific pathways and creating stunning features like glowing arcs and shock waves. These interactions not only sculpt the nebula's appearance but also influence where and how new stars can form. But magnetic fields don't just guide gas, they also play a role in slowing down the collapse of gas clouds. When a cloud of gas begins to collapse under gravity, magnetic fields exert a counteracting force, resisting the collapse and allowing the cloud to fragment into smaller, more manageable clumps. This process is essential for the formation of multiple stars within a single cloud, rather than one massive star. Over time, these clumps continue to collapse, eventually igniting nuclear fusion and giving birth to new stars. The influence of magnetic fields extends even further, shaping the environments around young stars. As these stars grow, they emit powerful stellar winds and radiation, which interact with the surrounding magnetic fields. This interplay creates dynamic structures like bow shocks and jets, which we've seen in earlier phenomena. These features not only add to the nebula's visual splendor, but also provide clues about the complex processes driving star formation. For astronomers, studying the magnetic fields of the Orion Nebula offers a unique opportunity to understand how these forces operate on a cosmic scale. By mapping the orientation and strength of these fields, scientists can piece together how they influence the distribution of gas and dust, the formation of stars, and even the potential for planetary systems to emerge. It's a reminder that even the most invisible forces can have a profound impact on the universe's grand design. As we explore the role of magnetic fields in the Orion Nebula, we gain a deeper appreciation for the delicate balance of forces that shape this stellar nursery. These fields, though unseen, are a vital part of the story, guiding the birth of stars and sculpting the nebula's breathtaking beauty. Next, we'll take a closer look at another fascinating feature: the vast regions of ionized gas that light up the Orion Nebula, creating its iconic glow. Stay with us as we continue to uncover the secrets of this cosmic wonder. Now, let's shift our focus to one of the most visually striking aspects of the Orion Nebula: its vast regions of ionized gas. These glowing clouds of charged particles are what give the nebula its iconic, ethereal appearance, painting the cosmos with vibrant hues of red, blue, and green. But what exactly causes this gas to light up, and how does it shape the nebula's breathtaking beauty? Let's dive in. The story begins with the young, massive stars at the heart of the Orion Nebula. These stars emit an incredible amount of ultraviolet radiation, which is so intense that it strips electrons from the atoms in the surrounding gas. This process, known as ionization, transforms the gas into a sea of charged particles, creating what astronomers call an ionized gas region. As these electrons recombine with atoms, they release energy in the form of light, causing the gas to glow in vivid colors. This is why the Orion Nebula appears so luminous and colorful when viewed through telescopes. But the ionized gas isn't just a pretty sight, it plays a crucial role in shaping the nebula's structure. The intense radiation from the young stars doesn't just ionize the gas, it also pushes it outward, creating vast bubbles and cavities within the nebula. These expanding regions of ionized gas carve out intricate patterns, sculpting the nebula into the stunning shapes we see today. In some areas, the gas forms delicate filaments and arcs, while in others, it creates towering pillars of dust and gas that resist the radiation's force. One of the most fascinating features of the ionized gas is how it interacts with the nebula's magnetic fields, which we explored earlier. The charged particles in the ionized gas are influenced by these magnetic fields, causing them to flow along specific pathways. This interaction creates dynamic structures like glowing arcs and shock waves, adding to the nebula's visual complexity. It's a cosmic dance of forces where radiation, gas, and magnetic fields all work together to shape the nebula's appearance. The ionized gas also serves as a cosmic laboratory, offering astronomers a chance to study the processes that drive star formation. By observing how the gas behaves, scientists can learn more about the conditions needed for stars to form and evolve. For example, the pressure from the ionized gas can compress nearby clouds of molecular gas, triggering the collapse of these clouds and the birth of new stars. It's a reminder that even the most beautiful features of the nebula are part of a larger, ongoing cycle of creation and destruction. As we marvel at the glowing ionized gas of the Orion Nebula, we're reminded of the incredible forces at work in the universe. These regions of charged gas not only light up the cosmos but also play a vital role in shaping the environments where stars are born. Next, we'll explore another intriguing aspect of the nebula: the dense, dark clouds of dust that create striking contrasts against its glowing gas. Stay with us as we continue our journey through this cosmic wonder. Now, let's turn our attention to the darker side of the Orion Nebula, its mysterious dark clouds. These dense regions of dust and gas may seem like voids in the nebula's glowing tapestry, but they hold secrets that are just as fascinating as the vibrant ionized gas we've explored. These dark clouds are not just empty spaces, they are cosmic nurseries where the next generation of stars is quietly taking shape. The dark clouds in the Orion Nebula are made up of tiny particles of dust and cold molecular gas. Unlike the ionized gas, which glows brightly under the influence of ultraviolet radiation, these clouds absorb light, making them appear as shadowy patches against the nebula's luminous background. This absorption of light is what gives them their striking, almost ominous appearance. But don't let their dark facade fool you. These clouds are teeming with activity. One of the most important roles of these dark clouds is their contribution to star formation. Within their dense interiors, the conditions are just right for gravity to take hold. As the dust and gas clump together under their own weight, they begin to collapse, forming dense cores. These cores are the seeds of future stars, and as they continue to collapse, they heat up, eventually igniting nuclear fusion and giving birth to new stars. In a way, these dark clouds are like cosmic cocoons, hiding the early stages of stellar life from view. But the dark clouds don't just hide stars, they also create some of the most dramatic visual contrasts in the Orion Nebula. When viewed through telescopes, these dark regions stand out sharply against the glowing gas, creating intricate patterns and textures. Some of the most famous examples are the dark lanes and filaments that weave through the nebula, giving it a three-dimensional appearance. These features are a reminder that the Orion Nebula is not just a flat, glowing cloud, but a dynamic, evolving structure with layers of complexity. Interestingly, the dark clouds also play a role in shaping the nebula's overall structure. As the ionized gas pushes outward, it encounters these dense regions of dust and gas which resist the radiation's force. This interaction creates towering pillars and ridges where the dark clouds act as shields, protecting the material behind them from being blown away. Over time, these pillars can become the birthplaces of new stars as the compressed gas within them collapses under its own gravity. As we explore the dark clouds of the Orion Nebula, we're reminded that even the most shadowy corners of the cosmos are filled with potential. These regions may seem quiet and unassuming, but they are the cradles of stellar life where the universe's next chapter is being written. Next, we'll delve into the powerful stellar winds that sweep through the nebula, shaping its landscape in dramatic ways. Stay with us as we continue to uncover the wonders of this cosmic masterpiece. Now, let's shift our focus to the invisible forces shaping the Orion Nebula stellar winds. These powerful streams of charged particles ejected from young, hot stars are like cosmic gusts that carve and mold the nebula's landscape. While we can't see them directly, their effects are unmistakable, leaving behind a trail of cavities, shock waves, and intricate structures in the surrounding gas. Stellar winds are born from the intense radiation and magnetic activity of young stars. As these stars burn through their nuclear fuel, they release energy not just as light, but also as streams of particles moving at incredible speeds. These winds can reach velocities of hundreds of kilometers per second, carrying enough force to push and compress the surrounding gas and dust. Over time, this relentless pressure sculpts the nebula, creating vast cavities and hollowed-out regions that give the Orion Nebula its complex, layered appearance. One of the most striking features created by stellar winds is the formation of shock waves. When these high-speed winds collide with slower-moving gas, they generate ripples of energy that travel through the nebula. These shock waves heat the gas, causing it to glow brightly and creating intricate patterns that astronomers can observe. In some cases, these collisions can even trigger new waves of star formation, as the compressed gas becomes dense enough to collapse under its own gravity. The impact of stellar winds isn't limited to shaping the nebula's structure. It also plays a crucial role in regulating star formation. By clearing away gas and dust, these winds can halt the growth of some stars while creating the conditions needed for others to form. It's a delicate balance where the destructive force of stellar winds also paves the way for new beginnings. This dynamic interplay between creation and destruction is one of the reasons the Orion Nebula remains such a fascinating subject of study. As we explore the effects of stellar winds, we're reminded of the incredible power hidden within the Orion Nebula. These invisible forces may not be as visually striking as the glowing gas or dark clouds, but their influence is undeniable. Next, we'll take a closer look at another dramatic result of these interactions: bow shocks, the glowing arcs of gas that mark the collision points between stellar winds and the surrounding material. Stay with us as we continue to unravel the mysteries of this cosmic wonder. Now, let's turn our attention to one of the most visually stunning results of stellar winds: bow shocks. These glowing arcs of gas are like cosmic fingerprints, marking the points where the high-speed winds from young stars slam into the slower-moving material around them. Imagine a boat cutting through water, creating ripples and waves in its wake. Bow shocks are similar, but on a much grander interstellar scale. Bow shocks form when the fast-moving stellar winds collide with the denser gas and dust in the nebula. The impact generates intense heat and pressure, causing the gas to glow brightly and creating these dramatic curved structures. These arcs can stretch for light years, and their shapes often resemble the bow of a ship, which is where they get their name. But unlike a ship's wake, bow shocks are not just fleeting ripples, they are powerful, long-lasting features that reveal a lot about the stars that create them. One of the key insights bow shocks provide is into the motion and energy of young stars. By studying the shape and brightness of these arcs, astronomers can determine the speed and direction of the stellar winds, as well as the density of the surrounding material. This information helps us understand how stars interact with their environment and how they influence the evolution of the nebula. For example, some bow shocks are so powerful that they can compress nearby gas, triggering the formation of new stars. It's a fascinating example of how destruction and creation are intertwined in the cosmos. Bow shocks also serve as cosmic laboratories for studying the physics of shock waves. The collisions that create these arcs release enormous amounts of energy, heating the gas to extreme temperatures and causing it to emit light across the electromagnetic spectrum. By analyzing this light, scientists can learn about the conditions within the shock waves, such as temperature, pressure, and chemical composition. These observations help refine our models of stellar dynamics and improve our understanding of how stars and nebulae evolve over time. As we marvel at the beauty of bow shocks, we're reminded of the incredible forces at work in the Orion Nebula. These glowing arcs are more than just stunning visuals, they are windows into the complex processes shaping the cosmos. Next, we'll explore another intriguing aspect of the Orion Nebula, the variable stars whose brightness fluctuates over time, offering clues about the life cycles of stars. Stay with us as we continue to uncover the secrets of this celestial wonder. Now, shifting our gaze to another fascinating feature of the Orion Nebula, we encounter the enigmatic variable stars. These celestial objects are anything but constant. Their brightness fluctuates over time, creating a cosmic dance of light that captivates astronomers and stargazers alike. Variable stars are like the heartbeat of the nebula, pulsing with energy and offering a glimpse into the dynamic processes at play in this stellar nursery. The changes in brightness of these stars can occur for several reasons. Some variable stars are intrinsic, meaning their fluctuations come from internal processes. For example, pulsating stars expand and contract, causing their brightness to rise and fall in a rhythmic pattern. Others are extrinsic, where changes in brightness are due to external factors, such as one star eclipsing another in a binary system. These variations, whether subtle or dramatic, provide a wealth of information about the stars themselves and the environment they inhabit. One of the most significant contributions of variable stars is their role in helping us understand stellar evolution. By observing how their brightness changes, astronomers can determine key properties like mass, temperature, and age. This data is crucial for piecing together the life cycles of stars, from their birth in dense clouds of gas and dust to their eventual demise. In the Orion Nebula, where star formation is still actively occurring, variable stars offer a unique opportunity to study young stars in various stages of development. Variable stars also serve as cosmic yardsticks. Certain types, like Cepheid variables, have a well-established relationship between their brightness and pulsation period. This makes them invaluable for measuring distances in space, helping astronomers map the structure of the nebula and even the broader universe. In the Orion Nebula, these stars provide insights into the three-dimensional layout of the region, revealing how stars are distributed and how they interact with their surroundings. Beyond their scientific value, variable stars add a layer of intrigue to the Orion Nebula. Their ever-changing light creates a dynamic and ever-evolving landscape, reminding us that the cosmos is far from static. As we continue to observe these stars, we uncover more about the forces that shape the nebula and the intricate dance of creation and destruction that defines it. With the mysteries of variable stars still unfolding, our journey through the Orion Nebula takes us next to its high-energy secrets, the X-ray emissions that reveal the hidden, violent processes occurring within this cosmic cradle. Stay tuned as we delve deeper into the heart of this celestial wonder. Now, let's turn our attention to a hidden layer of the Orion Nebula, one that can't be seen with the naked eye, but reveals some of the most energetic and violent processes in this cosmic region. We're talking about the X-ray emissions that radiate from deep within the nebula, offering a glimpse into the high-energy drama unfolding among its stars. These X-rays are primarily produced by young, hot stars, many of which are still in the early stages of their lives. As these stars form and grow, they generate intense magnetic fields and powerful stellar winds. When these winds collide with the surrounding gas and dust, they create shock waves that heat the material to millions of degrees, causing it to emit X-rays. This process is like a cosmic fireworks display, where the energy released is so immense that it pierces through the visible light we normally associate with the nebula. But it's not just the young stars that contribute to these X-ray emissions. Binary star systems, where two stars orbit each other, also play a significant role. In some cases, one star in the pair can pull material from its companion, creating a swirling disk of superheated gas. As this material spirals inward, it heats up and emits X-rays, adding to the nebula's high-energy glow. These interactions provide a window into the chaotic and dynamic relationships between stars in their formative years. What makes these X-ray emissions so fascinating is what they tell us about the environment within the Orion Nebula. They reveal regions of extreme turbulence and activity, where stars are not just born but also interact violently with their surroundings. By studying these emissions, astronomers can map out the distribution of hot gas, identify areas of intense star formation, and even track the movement of material as it's shaped by stellar winds and radiation. Moreover, X-ray observations have uncovered a surprising number of low-mass stars and brown dwarfs, objects too faint to be seen in visible light but glowing brightly in X-rays. These discoveries have expanded our understanding of the diversity of objects within the nebula, showing that it's not just massive stars that contribute to its energetic output. The X-ray emissions from the Orion Nebula remind us that there's more to this cosmic cradle than meets the eye. Beneath its stunning visible beauty lies a realm of high-energy processes, where stars are forged in the fires of creation and destruction. As we continue to explore these emissions, we gain deeper insights into the forces that shape not only the Orion Nebula but also the broader universe. With the high-energy secrets of the Orion Nebula now unveiled, our journey takes us next to its infrared glow, a hidden light that reveals even more about the mysteries of star formation and the dusty depths of this celestial wonder. Stay tuned as we uncover what lies beneath the veil of dust and gas. Now, let's peel back another layer of the Orion Nebula's mysteries, this time venturing into the realm of infrared light. While the nebula's visible beauty is breathtaking, much of its story lies hidden behind thick clouds of dust and gas. Infrared observations, however, allow us to peer through this cosmic veil, revealing a world of star formation that would otherwise remain invisible. Infrared light has a unique ability to penetrate the dense dust that blankets parts of the Orion Nebula. Unlike visible light, which gets absorbed or scattered by these particles, infrared wavelengths pass through, illuminating the hidden structures and processes within. This capability has revolutionized our understanding of the nebula, uncovering regions where stars are born in the shadows of dust clouds. One of the most striking discoveries made through infrared observations is the sheer number of young stars and protostars embedded within the nebula. These objects, still in the early stages of formation, are often shrouded in thick cocoons of gas and dust. In visible light, they remain completely obscured, but infrared telescopes like the Hubble Space Telescope and the James Webb Space Telescope have revealed their presence in stunning detail. These observations show us not just the stars themselves, but also the intricate disks of material surrounding them, disks that may one day coalesce into planets. Infrared light also allows us to map the distribution of dust and gas throughout the nebula, providing a clearer picture of its structure. By studying how infrared light interacts with these materials, astronomers can determine their temperature, density, and composition. This information is crucial for understanding how stars form and how the nebula evolves over time. For instance, infrared observations have shown that some regions of the nebula are much colder and denser than others, indicating areas where future star formation is likely to occur. Another fascinating aspect of the nebula's infrared glow is its ability to reveal the presence of complex molecules. These molecules, often referred to as the building blocks of life, are found in abundance within the Orion Nebula. Infrared spectroscopy has identified water, carbon monoxide, and even organic compounds like methanol in the nebula's gas clouds. These discoveries not only deepen our understanding of the nebula's chemistry, but also provide clues about the conditions necessary for life to emerge elsewhere in the universe. The transformative power of infrared observations extends beyond the Orion Nebula itself. By studying how stars form in this nearby stellar nursery, astronomers can apply these insights to other regions of the galaxy and beyond. The Orion Nebula serves as a laboratory for understanding the universal processes of star and planet formation, and infrared light is one of our most powerful tools for exploring these phenomena. As we continue to uncover the secrets hidden within the nebula's infrared glow, we gain a deeper appreciation for the complexity and beauty of this cosmic cradle. From the birth of stars to the chemistry of life, the Orion Nebula's infrared light reveals a universe of wonders that lies just beyond the reach of our eyes. With the hidden world of infrared now unveiled, our journey takes us next to the radio waves emitted by the Orion Nebula, a different kind of light that offers yet another perspective on this celestial marvel. Stay tuned as we explore how these waves reveal the cold, dense regions of gas and dust that shape the nebula's evolution. Now, shifting our gaze to a different kind of light, let's tune into the radio waves emanating from the Orion Nebula. While infrared light reveals the hidden warmth of star-forming regions, radio waves offer a unique window into the coldest and densest parts of the nebula. These waves, invisible to our eyes, carry secrets about the gas and dust that shape the nebula's structure and future. Radio waves are particularly useful for studying the coldest regions of the Orion Nebula, where temperatures can drop to just a few degrees above absolute zero. In these frigid environments, gas and dust clump together, forming dense clouds that are often the birthplaces of new stars. Unlike visible or infrared light, radio waves can pass through these thick clouds with ease, allowing astronomers to map their distribution and study their properties in detail. One of the key tools for observing these radio emissions is the Atacama Large Millimeter Array, or ALMA, a powerful radio telescope located in the high deserts of Chile. ALMA's ability to detect faint radio signals has provided unprecedented views of the nebula's cold, dark regions. These observations reveal intricate networks of filaments and knots within the gas, where gravity slowly pulls material together to form stars. By analyzing the radio waves emitted by these structures, scientists can measure their density, temperature, and motion, offering clues about how stars and planetary systems take shape. Radio observations also allow astronomers to study the chemical composition of the nebula's gas clouds. Molecules like carbon monoxide, ammonia, and even complex organic compounds emit specific radio frequencies, acting as fingerprints that reveal their presence. These molecules are crucial for understanding the chemistry of star-forming regions and the potential for life to emerge in other parts of the universe. For example, the detection of complex organic molecules in the Orion Nebula suggests that the building blocks of life may be common in similar environments across the galaxy. Another fascinating aspect of the nebula's radio emissions is their ability to trace the magnetic fields that permeate the region. Magnetic fields play a critical role in shaping the flow of gas and dust, influencing how stars form and evolve. By studying the polarization of radio waves, astronomers can map these invisible fields, gaining insights into their strength and orientation. This information helps us understand how magnetic forces interact with gravity and radiation to sculpt the nebula's intricate structures. The study of radio waves from the Orion Nebula not only deepens our understanding of this stellar nursery, but also provides a template for exploring other star-forming regions in the universe. By comparing the radio emissions from the Orion Nebula to those from distant galaxies, scientists can uncover universal patterns in the birth and evolution of stars. As we continue to listen to the whispers of radio waves from the Orion Nebula, we uncover a symphony of cosmic processes that shape the universe. From the coldest clouds of gas to the magnetic fields that guide them, these observations reveal the hidden forces at work in this celestial wonder. With the secrets of radio waves now unveiled, our journey takes us next to the cosmic rays that ripple through the Orion Nebula, a phenomenon that adds yet another layer of mystery to this already enigmatic region. Stay tuned as we explore how these high-energy particles interact with the nebula's gas and dust, shaping its evolution in ways we are only beginning to understand. Now, let's turn our attention to a phenomenon that adds a high-energy twist to the Orion Nebula's story: cosmic rays. These mysterious particles, traveling at nearly the speed of light, are constantly streaming through space, and the Orion Nebula is no exception. But what exactly are cosmic rays, and how do they influence this stellar nursery? Cosmic rays are not rays in the traditional sense, but rather high-energy particles, mostly protons and atomic nuclei, that zip through the universe. They originate from some of the most violent events in space, such as supernova explosions, black hole jets, and even the powerful winds from massive stars. When these particles collide with the gas and dust in the Orion Nebula, they create a cascade of interactions that can shape the nebula's environment in surprising ways. One of the most fascinating aspects of cosmic rays is their ability to ionize the gas they encounter. As these high-energy particles smash into atoms within the nebula, they strip away electrons, creating charged particles. This process not only heats the gas but also influences its chemistry, triggering reactions that can lead to the formation of complex molecules. In fact, cosmic rays may play a key role in creating the building blocks of life, such as amino acids, within the nebula's dense clouds. But cosmic rays don't just affect the gas, they also leave their mark on the nebula's dust. When these particles collide with dust grains, they can shatter them into smaller pieces or even vaporize them entirely. This process, known as sputtering, releases atoms and molecules back into the gas, altering the nebula's chemical makeup. Over time, these interactions can shape the distribution of dust and gas, influencing where and how new stars and planets form. Interestingly, cosmic rays also help astronomers map the structure of the Orion Nebula. By studying how these particles are absorbed or deflected as they travel through the nebula, scientists can infer the density and distribution of its gas and dust. This information provides valuable clues about the nebula's internal dynamics and the forces driving its evolution. The presence of cosmic rays in the Orion Nebula also raises intriguing questions about their impact on star formation. Some researchers believe that the energy deposited by these particles could either trigger or suppress the collapse of gas clouds, depending on the conditions. This delicate balance between creation and destruction adds another layer of complexity to our understanding of how stars are born. As we explore the role of cosmic rays in the Orion Nebula, we're reminded of the interconnected nature of the universe. From the violent origins of these particles to their subtle influence on the nebula's chemistry and structure, cosmic rays are a testament to the dynamic processes that shape the cosmos. With this high-energy phenomenon now in focus, our journey through the Orion Nebula continues as we delve into its chemical composition, a topic that reveals even more about the ingredients that make this celestial wonder so extraordinary. Stay with us as we uncover the molecular secrets hidden within its swirling clouds. Now, let's shift our gaze to the very building blocks of the Orion Nebula, its chemical composition. This celestial wonder isn't just a swirling mass of gas and dust. It's a cosmic laboratory brimming with complex molecules that hold the secrets to star and planet formation. By studying the nebula's chemical makeup, scientists can piece together the conditions that give rise to new worlds and stellar systems. At the heart of the Orion Nebula lies a rich tapestry of elements, from the simplest atoms like hydrogen and helium to more complex molecules such as water, carbon monoxide, and even organic compounds. These molecules are scattered throughout the nebula, embedded in its vast clouds of gas and dust. But how do they form, and what role do they play in shaping the nebula's future? One of the most intriguing aspects of the Orion Nebula's chemistry is the presence of complex organic molecules. These include compounds like methanol, formaldehyde, and even amino acids, the very building blocks of life. While these molecules don't guarantee the existence of life, they do suggest that the ingredients for life as we know it are scattered throughout the cosmos. The formation of these molecules is driven by a combination of factors, including the intense radiation from young stars, the shock waves from stellar winds, and the collisions between cosmic rays and gas particles. The process of molecule formation in the Orion Nebula begins with the simplest atoms. Hydrogen, the most abundant element in the universe, pairs with other atoms to form molecules like molecular hydrogen, which serves as the primary fuel for star formation. As these molecules collide and interact, they give rise to more complex structures. For example, carbon atoms can bond with oxygen to form carbon monoxide, a molecule that plays a crucial role in cooling the gas and allowing it to collapse into dense clouds. These clouds, in turn, become the birthplaces of new stars and planets. But the chemistry of the Orion Nebula doesn't stop there. The intense ultraviolet radiation from young stars ionizes the surrounding gas, creating a hot, turbulent environment where chemical reactions occur at an accelerated pace. This radiation can break apart molecules, but it can also trigger the formation of new ones. For instance, when water molecules are split by ultraviolet light, the resulting oxygen atoms can combine with other elements to form more complex compounds. The presence of dust grains in the nebula also plays a critical role in its chemistry. These tiny particles act as catalysts, providing surfaces where atoms and molecules can meet and react. On the surfaces of dust grains, simple molecules can combine to form more complex ones, including those that are essential for life. Over time, these grains can become coated with icy layers of water, methane, and other compounds, creating a rich chemical environment that fuels the formation of stars and planets. By studying the chemical composition of the Orion Nebula, astronomers gain valuable insights into the processes that drive star and planet formation. The presence of complex molecules suggests that the conditions for creating planetary systems and potentially life are not unique to our own solar system. Instead, they may be a common feature of star-forming regions throughout the universe. As we uncover the molecular secrets of the Orion Nebula, we're reminded of the intricate interplay between chemistry and physics in shaping the cosmos. From the simplest atoms to the most complex molecules, the nebula's chemical makeup tells a story of creation, destruction, and the endless cycle of stellar birth and death. With this deeper understanding of the nebula's chemistry, our journey now takes us to its role in ancient astronomy, a fascinating chapter that reveals how this celestial wonder has captured the imagination of humanity for centuries. Stay with us as we explore the myths, legends, and early observations that have shaped our understanding of the Orion Nebula. Now, let's step back in time and uncover how the Orion Nebula has fascinated humanity for centuries. Long before modern telescopes revealed its intricate details, this celestial wonder held a special place in the hearts and minds of ancient cultures. Its presence in the night sky inspired myths, legends, and early astronomical observations that shaped our understanding of the cosmos. In many ancient civilizations, the Orion Nebula was not just a cluster of stars but a symbol of divine power and cosmic order. The constellation of Orion, which houses the nebula, was often associated with gods, heroes, and creation myths. For the ancient Egyptians, Orion was linked to Osiris, the god of the afterlife and resurrection. They believed that the stars of Orion represented Osiris's eternal journey through the heavens, a celestial reflection of life, death, and rebirth. The nebula itself, though not visible to the naked eye, was thought to be a part of this sacred narrative, a hidden realm where the gods worked their magic. Similarly, in Greek mythology, Orion was a mighty hunter immortalized in the stars after his death. The nebula, nestled within his celestial form, was seen as a place of mystery and wonder. Some ancient Greek astronomers even speculated that the faint glow around Orion's sword might be a sign of divine activity, though they lacked the tools to study it in detail. These early interpretations reveal how the Orion Nebula became a canvas for human imagination, blending science and storytelling in ways that still resonate today. Moving to the ancient Mayans, Orion held a different but equally profound significance. They associated the constellation with their maize god, a symbol of fertility and sustenance. The nebula, though unseen, was believed to be a source of cosmic energy that influenced the cycles of life on Earth. This connection between the heavens and the natural world highlights how ancient cultures saw the Orion Nebula not just as a distant object but as an integral part of their spiritual and agricultural practices. Early astronomers, armed with little more than their eyes and rudimentary tools, also made important observations about Orion. The Persian astronomer Al-Sufi, writing in the 10th century, described the stars of Orion in great detail, though he did not mention the nebula itself. It wasn't until the invention of the telescope in the 17th century that the Orion Nebula was officially discovered and documented. Yet, even without advanced technology, ancient stargazers recognized the constellation's importance, using it to navigate the night sky and mark the changing seasons. The Orion Nebula's role in ancient astronomy reminds us that humanity's fascination with the cosmos is as old as civilization itself. From myths and legends to early scientific observations, this celestial wonder has always been a source of inspiration and curiosity. Its story is a testament to the enduring connection between the stars above and the stories we tell here on Earth. As we reflect on the nebula's place in ancient cultures, our journey now turns to its future, a future filled with new discoveries, evolving structures, and the potential for even more cosmic wonders. Stay with us as we explore what lies ahead for the Orion Nebula and the mysteries it still holds. As we turn our gaze toward the future, the Orion Nebula continues to be a dynamic and ever-changing region of space. Over the next millions of years, this cosmic cradle of stars will undergo dramatic transformations, shaping the destiny of its stellar inhabitants and the surrounding gas and dust. The processes at work within the nebula today will set the stage for new generations of stars and planets, offering a glimpse into the ongoing cycle of creation in the universe. One of the most fascinating aspects of the Orion Nebula's future is its role as a stellar nursery. The dense clouds of gas and dust within the nebula are still actively forming new stars, and this process shows no signs of slowing down. As gravity continues to pull material together, these clouds will collapse, igniting the birth of countless new stars. Some of these stars will be massive, burning brightly and briefly, while others will be smaller, like our Sun, with the potential to host planetary systems of their own. This ongoing star formation ensures that the Orion Nebula will remain a vibrant and bustling region for millions of years to come. But the story doesn't end there. As these new stars emerge, their intense radiation and powerful stellar winds will continue to shape the nebula, carving out cavities and pushing the surrounding gas and dust into new configurations. Over time, these forces will erode the nebula's structure, dispersing its material into space. While this may sound like the end of the Orion Nebula as we know it, it's actually the beginning of a new chapter. The dispersed material will eventually become part of other molecular clouds, seeding the formation of future stars and planets in other regions of the galaxy. Another exciting possibility lies in the potential for planet formation within the nebula. The protoplanetary disks or proplyds observed around young stars in the Orion Nebula are the building blocks of future planetary systems. Over time, these disks will coalesce into planets, moons, and other celestial bodies, creating entirely new worlds. Some of these planets may even lie within the habitable zones of their stars, raising the tantalizing possibility of life beyond Earth. The Orion Nebula, in this sense, is not just a place of stellar birth, but also a potential birthplace of life itself. As we look further into the future, the Orion Nebula will eventually fade from view, its material scattered across the galaxy. But its legacy will endure. The stars born within its clouds will continue to shine, and the planets formed from its dust may one day host civilizations that look up at the night sky just as we do today. The Orion Nebula's story is a reminder that the universe is in a constant state of change, with each ending giving rise to new beginnings. With this glimpse into the future, we now turn to the Orion Nebula's impact on our understanding of the cosmos. From its role in advancing astronomy to the mysteries that still remain, the nebula continues to inspire and challenge us. Stay with us as we explore how this celestial wonder has shaped our knowledge of the universe and what questions it still holds for future generations. Now, let's shift our focus to the profound impact the Orion Nebula has had on the field of astronomy. This celestial wonder has served as a cosmic laboratory, offering astronomers a front-row seat to the processes that shape the universe. From star formation to stellar evolution, the Orion Nebula has provided invaluable insights that have transformed our understanding of how stars and planetary systems come into being. One of the most significant contributions of the Orion Nebula lies in its role as a stellar nursery. By studying the trapezium cluster and the surrounding regions, astronomers have been able to observe the earliest stages of star formation in unprecedented detail. The intense radiation from young stars, the swirling protoplanetary disks, and the dynamic interactions within the nebula have all provided critical clues about how stars are born. These observations have not only deepened our knowledge of star formation, but have also helped refine models that predict how stars evolve over time. The Orion Nebula has also been instrumental in advancing our understanding of stellar evolution. The presence of massive stars, like those in the trapezium cluster, has allowed scientists to study the life cycles of stars that burn brightly and die young. These massive stars play a crucial role in shaping their surroundings, ionizing gas, and triggering further star formation. By observing these processes, astronomers have gained a clearer picture of how stars influence their environments and how they contribute to the chemical enrichment of the galaxy. Another area where the Orion Nebula has made a significant impact is in the study of planetary system formation. The discovery of proplyds or protoplanetary disks within the nebula has provided a direct look at the early stages of planet formation. These swirling disks of gas and dust are the birthplaces of future planets, and their study has shed light on the conditions necessary for planetary systems to emerge. The Orion Nebula has become a key reference point for understanding how planets, including those in our own solar system, come into existence. Beyond star and planet formation, the Orion Nebula has also deepened our understanding of the life cycle of nebulae. The interplay between ionized gas, magnetic fields, and stellar winds within the nebula has revealed how these structures evolve over time. From the dense molecular clouds that give birth to stars to the eventual dispersal of material into space, the Orion Nebula has provided a comprehensive view of the dynamic processes that govern the life and death of nebulae. As we continue to study the Orion Nebula, it remains a source of inspiration and discovery. Its contributions to astronomy have not only expanded our knowledge but have also raised new questions that drive further exploration. From the mysteries of star formation to the potential for life-bearing planets, the Orion Nebula continues to challenge and inspire us, reminding us of the endless wonders waiting to be uncovered in the cosmos. With this understanding of its impact, we now turn to the mysteries that still surround the Orion Nebula. What secrets does it hold, and what questions remain unanswered? Stay with us as we delve into the enigmas that keep astronomers intrigued and eager to learn more. Now, as we venture deeper into the Orion Nebula's mysteries, we find ourselves standing at the edge of the unknown. Despite all we've learned, this cosmic wonder continues to guard secrets that challenge even the most advanced telescopes and theories. What are the most puzzling questions that remain unanswered, and what do they tell us about the limits of our understanding? One of the most intriguing mysteries lies in the nature of the Beckmann-Neugebauer object. This enigmatic infrared source, hidden deep within the nebula, is believed to be one of the youngest stars in the region. Yet, its exact origins and the processes that shaped it remain unclear. Is it a single star, or could it be a binary system? And how did it form in such a dense, chaotic environment? These questions remind us that even the youngest stars can hold secrets that defy explanation. Another puzzle revolves around the Kleinman-Low Nebula, a dense and dusty region teeming with massive star formation. While we know it's a hotspot for the birth of high-mass stars, the mechanisms that trigger such intense activity are still not fully understood. What drives the formation of these massive stars, and how do they influence the surrounding gas and dust? The answers could reshape our understanding of how the most massive stars in the universe come to life. The integral-shaped filament, a massive, twisted structure of gas and dust, also presents a fascinating challenge. Its unique geometry suggests the influence of powerful magnetic fields, but the exact forces at play remain elusive. How do these magnetic fields interact with the gas and dust to create such intricate shapes? And what role do they play in the overall evolution of the nebula? These questions highlight the complex interplay of forces that shape the cosmos. Even the Orion Nebula's chemical composition holds mysteries. While we've detected complex molecules within its clouds, the exact conditions that allow these molecules to form and survive are still being explored. Could these molecules be the building blocks of life? And if so, what does that mean for the potential of life elsewhere in the universe? The nebula's chemistry may hold clues to one of the most profound questions of all: are we alone? Finally, the future of the Orion Nebula itself is a mystery. While we can predict its evolution over millions of years, the exact path it will take remains uncertain. Will it continue to birth new stars and planets, or will it eventually disperse into the void? And what will its legacy be in the grand tapestry of the universe? These unanswered questions remind us that the Orion Nebula is more than just a beautiful cosmic spectacle. It's a frontier of discovery. Each mystery invites us to look deeper, to question what we know, and to imagine what lies beyond our current understanding. As we continue to explore, the Orion Nebula promises to reveal even more about the universe and our place within it. So, what do you think is the most fascinating mystery of the Orion Nebula? Let us know in the comments, and don't forget to subscribe for more cosmic explorations. As we wrap up our journey through the Orion Nebula, it's impossible not to be struck by the sheer complexity and beauty of this cosmic wonder. From the trapezium cluster's intense radiation to the enigmatic Beckmann-Neugebauer object, and from the swirling proplyds to the dramatic Herbig-Haro jets, each phenomenon we've explored reveals a piece of the nebula's intricate puzzle. The Orion Nebula is not just a static image in the night sky. It's a dynamic, ever-changing region where stars are born, planets take shape, and mysteries abound. The Orion Bar, the Horsehead Nebula, and the integral-shaped filament remind us of the delicate balance between light and shadow. while the nebula's magnetic fields, ionized gas, and stellar winds showcase the powerful forces at work. Even the chemical composition of the nebula hints at the potential for life beyond our planet, sparking questions about our place in the universe. And as we look to the future, the Orion Nebula continues to challenge our understanding, promising new discoveries with every observation. So, which of these 25 phenomena captivated you the most? Was it the iconic Horsehead Nebula, the mysterious Beckmann-Neugebauer object, or perhaps the swirling proplyds that could one day form new worlds? Let us know in the comments below. We'd love to hear your thoughts. If you enjoyed this deep dive into the Orion Nebula's strangest phenomena, don't forget to hit the like button, subscribe to our channel, and ring the notification bell so you never miss out on more cosmic explorations. The universe is full of wonders waiting to be uncovered, and we can't wait to share them with you. Until next time, keep looking up. The stars have so much more to reveal.